Share the screen. All right, now we are actually very ahead, okay, quite a bit ahead. I was finished with 9.1, which means I could start on 9.2. On the original schedule, I wasn't supposed to start on 9.2 until next Thursday. Okay, so here's what I'm going to do, and we're not going to just quit. I'll lecture maybe about half of 9.2. It doesn't really make sense to do all of 9.2 in one day anyway. It's a natural division, like maybe right around here. Okay. So I'll do this part of 9.2, and then when I'm finished, I'll go ahead and give you the quiz. That might just be the first half. So maybe this is the first half. Second half, you just take the quiz, and then we're done. Okay? So that's what I think I'll do. So I'll probably go up to maybe around 14-ish. And then I'll stop and I'll give you a quiz. Okay. And as usual, I'll break you up into your breakout groups. But once you get going, you can stop anytime you want and submit the quiz by next Tuesday. But one thing about quizzes, some of you already noticed this, even though it's not due until next Tuesday at the start of class, if you submit it early enough, I can maybe make comments on it and say, try this in case you don't get full credit. Okay. And some of you already noticed that. I try to respond to all my emails within 24 hours. Quite often it's much earlier than that. But let's say you submit the quiz Saturday, I'll get to it by Sunday. Or you submit the quiz on Sunday, I'll get to it by Monday. And then if you get the full 5 out of 5, great, you're done. But if you don't, then I might say, okay, this was not quite right. Try this, try that, try the other thing. And then if you resubmit it, you fix it up, then I can give you full credit. And some of you have already taken advantage of that. I mean, how much low pressure can there be on a quiz, right? So you can help each other out. You can talk about it with your breakout room mates. You can use your book, you can use your notes. You got the whole weekend. And even when you submit it, if it's early enough, I can even make comments and say, try this, and then you can resubmit it. Okay. Now, obviously, if you wait until, what, 6:58 or 7:04 or something like that, next Tuesday to submit the quiz, I'll take it, but you know, obviously I won't have a chance to look at it and possibly give you a second chance at the quiz. Okay, so one advantage of submitting your quizzes early is that in case something's not right, then I might have a chance to suggest, okay, try this and try this and try this, okay? All right, so 9.1 is what I'll get started, 9.2. Okay, so we're still on differential equations. So last time we were doing the baby differential equations, show and tell, right? Show that blah, blah, blah works. Okay, so what's happening in 9.2 now? Okay, so 9.2, the topic is direction fields or slope fields. Direction fields and Euler's method. Okay, I'm going to hold off on Euler's method. We'll just do direction fields. So I'll do Euler's method next time. So as a method, Euler's method is what? 19 and 21 and 24. So 1 through 14, that's going to be direction fields. Or you can say slope fields. Let me just show you what we're up against. Here's a direction field or a slope field. Okay. This happens to be y prime equals x plus y. Differential equation. Okay. And all these things here. And this is considered a solution curve to this. Now, this is obviously computer generated. Okay. You're actually going to make some of these. Okay. Now, don't get too scared yet. I'm not going to have you do, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 11, 121. You won't have to do 121 of these. Okay, yours is going to be much smaller. Okay, so y prime equals x plus y looks like this. How do you get it? It's actually not that bad a concept, but it's a little bit tedious. Okay, here's a solution curve through 0, 1. So if I have the point 0, 1, if you look at the way the lines are going, if you have a point here, if you kind of follow the lines there, it looks like it's coming here. And the way these are curving over here, it could have come from here. So this is a possible solution curve. Yeah, granted, we're just guesstimating right here. We're just guessing that it looks something like that. Okay. Just by example, here's some more. This is on page 593. Here's a slope field or direction field. Okay. Here's one that happens to go through the origin. So if you look at the origin, right? Pretend this is a slope field. You drop a particle here. Okay. Maybe this is fluid flow or electron flow or air flow, right? So if you drop a particle at the origin, it looks like it's going that way. And then maybe it starts to curve up. So like so. And then where could it have come from? Looks like maybe it's going like that, and it swings down this. So it goes something like this. Right? So this is a slope field. This could be the direction of a field. It could be a force field, electric field, magnetic field, okay? Fluid flow, like of a liquid, or air flow. Okay? You know, one of the big issues nowadays, especially with COVID, is airflow, right? You want to have air circulation and airflow. And so these are slope fields, okay? And by making advantage of certain things, you can get air to flow or water to flow a certain way, right? Okay, and then figure 7, you don't really have to take notes now, okay? But here's another one. And so these are all different solution curves depending on where you first drop the particle, so to speak. So let's say this is fluid flow or flow of water, and you happen to drop, let's say, a leaf. You drop a leaf right here. Okay, so where's it going to go? Maybe like that, or where could it have come from? It's like that. Or if you're over here, then maybe it would flow like that. Or if you're over here, then maybe it would go like that, and so on, right? So maybe there's the flow of water or the flow of air, as it were. Okay. And here's some more. So this is an interesting one. Looks like this is what, y equals 5. If you happen to drop the particle right at y equals 5, it kind of just stays there. And if you drop something below, it curves toward y equals 5. And if you drop something above, it still curves toward y equals 5. It's kind of a funnel effect. So it's almost like no matter where you drop the particle, it's going to move toward y equals 5. Okay, they put the symbolic limit as t approaches infinity of the function of t is equal to 5. Okay, so as I go to the right, right, no matter if I drop it here or here or right here or right here, they're all seeming to curve toward y equals 5. Sort of like a funneling effect. Okay. All right, so 1 and 2. Now, unfortunately, we're not meeting on campus. If we were meeting on campus, I would have a way of showing this to you better because I can use the board. But since I can't use the board, I can only quote unquote fake it. So sorry, all I can do is just fake these to you, as it were. Okay, so 1 and 2. Start off with number 1. A direction field for the differential equation y prime equals x cosine of pi y is shown. Okay, so they have all of these things. You will actually make something like this. Okay, now don't worry, this is computer generated. You won't have to do this many. I mean, offhand, this is maybe, I don't know, 15 by 15, 225. Okay, you are quote unquote only going to do 49. Okay, you might guess where it's 49. 49 is equal to 7 times 7. Okay, so you're only going to go 7 by 7, and I'll show you how to do that. But in any event, this is what they're giving me. This differential equation, y prime equals a function of x and y. Okay, so this kind of differentiation, differential equation just has y prime on the left side, and the right side has something involving x and y, perhaps. Okay, and they came in with this. All right, so all they want you to do is sketch the graph given these initial conditions. Okay, now you usually start off at 0. Notice this is y of 0, y of 0, y of 0, y of 0. Okay, but you don't have to start at 0. but this time they did. But you could start at 1. Yeah, over here. You just start at 1, let's say. All right, so it's asked us to say, if you were to drop the particle there, which way is it going and which way could it have come from? Okay, so the only thing I'm going to do, and it's not that good of a job, but you'll have to kind of watch what I'm doing based on these lines. Okay, y of 0 equals 0. Okay, so I'm at the origin. You drop the particle right at the origin. Look at the way the lines are going. It looks like it's going to curve up like that. And it could have come from over here, let's say. Okay, so what am I going to do right now? Best thing I can do is maybe this. So draw something without the lines now. Okay, it looks like 0.5, 1.5. I got straight lines across. Okay, so that's supposed to mimic this. I'm certainly not going to draw all the lines. Okay, but for 0, the way it's going, I'm going to say it looks something like that. Okay, now, we were meeting on campus. I have a way of superimposing this right onto that. Okay, so what I'm drawing is right here. So that's the best I can do. Okay, so that's I. Okay, 2. Y of 0 is 0.5. That's right on this line. So I would say that one's just going to be a horizontal line. So the second one just goes along here. So y of 0 is 0 means 0, 0. The second one was 0, 0.5. That's 0.5 there. Okay. Y of 0 is 1. Okay, 1 is here. So if you look at the way the lines are going, it looks like it's curving down here, and it's also curving down here. Okay, so I'm going to say that one goes something like that. 0, 1. Okay, so 0, 0, 0, comma 0.5, or 0.5, 0, 1. The last one says 1.6, which is a little bit above 1.5. And it looks like they're going up on both sides. Okay, so it looks like that one's going to go like so. Okay, so here are the 4 solutions. As it were. Okay, so 0, 0. If you drop the particle right there, the way the lines are going, it's curving towards 0.5 and also there. Okay, if I drop the particle, the leaf, as it were, at 0, 0.5, it's right on this straight horizontal line. And then 0, 1 is over here. Looks like we're curving down and curving down. And then 0, 1.6. 1.5 is here. 1.6 is a little bit higher. Looks like it's curving up there and curving up there. Okay, so that's what I have for that. Okay. All right, B, find the equilibrium solutions. Y equals 0.5, y equals 1.5. Those are called equilibrium solutions. Okay, so equilibrium solutions, 1B, equilibrium solutions. Y equals a constant. Y equals a constant number, which of course means y prime is 0. All right, now it looks like I have 0.5, 1.5. So maybe the next one will be 2.5, 3.5, and so on. Let's actually see that. Okay, if I plug in 0.5 for y right here, 0.5 times pi, that's like pi over 2. Cosine of pi over 2 is 0, which means the derivative is 0. That's true. 1.5 is the same as 3 over 2. So I will be taking the cosine of 3 pi over 2. That's also 0. Okay, so yes, indeed, it looks like to get them all, I can take 0.5, 1.5, 2.5, 3.5, and negative 0.5, negative 1.5, and so on. So it looks like for the equilibrium solutions, I would say y equals 0.5 plus a integer, so plus n, where n is an integer. So that includes 0.5, 0.5 plus 1, 0.5 plus 2, 0.5 plus 3, 0.5 minus 1, 0.5 minus 2, 0.5 minus 3. And those are all the equilibrium solutions. Okay. All right, and then number 2, pretty much the same thing. This one's curving like this somehow. So y prime equals tangent of half pi y translates to all this stuff. Okay. So here's the slope field. Sketch the graph of the solution to satisfy. Okay, so we'll try to do the same thing. So it looks like equilibrium solutions. I have one down at y equals 0, y equals 2, y equals 4. So maybe the way it's going is 6, 8, 10, and so on, and negative 2, negative 4, and so on. Okay, so the way this one is going, it looks like it's curving over and then it swings back. Curving over and swings back offhand. Okay. So let me try to draw these. And I can't show it to you as well as if I could just superimpose on the board, but I'll do the best I can. Okay, so see, this one is going from 0 up to 4. Let's see. Zero to 4. Okay, so 2 is going something like this, and 4 is going something like this. Okay, this must be, so these are my equilibrium solutions. Okay, y of 0 is 1. Okay, so take a look right here. It's curving over and curving over. Okay. So I'm going to go like this. 0, 1. Y of 0 equals 1 means the point is 0, comma 1. Or think of the ordered pair. Just forget about the y, and it's 0, comma 1, 0, comma 2, 0, comma 0.2, 1, comma 3. Okay, 0, comma 0.2. That's over here. So that one, it's going to swing over, and then it looks like it still comes back up. So it swings a little bit wider. So it's going to still end up going something like that. So 0, comma 0.2 will look something like that. It's going to keep going for a little, and then it seems like it comes up, and then it swings back over. Okay, y of 0 equals 2. Well, that's just along this horizontal line, right? So that one, I can just go like that. 0, 2. Right? It's just a horizontal line. And finally, 1, 3. So that's over here somewhere. So over here, again, the way the lines are going, you would swing that way and swing that way. Okay. So just put 1, 3 over here somewhere. And again, it's curving like that and like that. Okay. So that's it. So if you drop the particle at 0, 1, the way it's curving, something like that. 0, comma 0.2, I've got it like that. Look at the way the lines are going like that and like that. Y of 0 equals 2, that's right on my equilibrium solution. And 1, comma 3 is right there. And again, it's curving, but it's on this upper branch here. So again, like so. Okay. And find all the equilibrium solutions. So it looks like 0, 2, 4, 6. So the even numbers. Okay, so how do I write the even numbers? y equals 2n, where n is an integer. Okay. So if I plug in 0, I get 0. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in -1, I get -2, and so on. Okay. All right, so that is it. So I'm done with 1 and 2. And now for the rest of them, here are some more slope fields. Okay. You're going to make these slope fields now. Okay. It's a lot of work, a lot of computation. Okay. You know how to compute as well as I do, so I'm going to save a lot of time by just giving you the final result, but I'll just point to some of them for you. But see all these different lines here? Okay. I mean, this is, I'm going to guess that's 10. 10, 10, 20, 20 by 20 is 400. Okay, 400. You don't have to do 400. You, quote unquote, only have to do, like I said, 49. Okay. All right, so I'll let you try 7 and 8 on your own. It's pretty much the same idea. Okay, so 7 and 8. So use the direction field labeled 1. Okay, so question 7, you do it to this one. And question 8, you do it to this one. Okay. All right, now, how do you come up with these direction fields now? Okay, so that's 9 through 14. Sketch a direction field for the differential equation, then use it to sketch 3 solution curves. Okay, so how do you do that? Okay, now what I'm going to show you is actually the whole thing already completed. To do one of them takes quite a bit of time. Okay, but you basically have to come up with a table. Okay. So here we are. Start over here. We will make, that's make, slope fields, direction fields, using lattice points on -3, 3 cross -3, 3. Okay, what's a lattice point? A lattice point is an ordered pair where x and y are integers. They are quote unquote nice points. Okay? No fractions, no decimals. Both x and y are integers. So that's called a lattice point. So that means we're quote unquote only going to go -3, -2, -1, 0, 1, 2, 3 for x. That's 7, right? And same thing, -3, -2, -1, 0, 1, 2, 3 for y. So we're only going to do 49. Fortunately, once you kind of get the pattern, sometimes once you see the pattern, a pattern develops, then you can do it fairly rapidly. All right, so how do we do this? So you're going to make a table. If you want to use this as an example table, you may. So see how I have x, -3, -2, -1, 0, 1, 2, 3. Y, -3, -2, -1, 0, 1, 2, 3. So the start of all of these problems is like this. Okay, so every problem starts -3 to 3 for x, 3 to -3 for y. It has to be in this order because that's the way it is on the xy plane. Okay. For x, -3 is on the left, +3 is on the right. Okay, and for y, +3 is up, -3 is below. So you might want to go -3, -2, -1, 0, 1, 2, 3, but go this way. Okay, it makes it better. I'm trying to cover up this part here. Oops, sorry, don't mean to burn out your eyeballs though. Right, so every one of these kind of problems starts like this. Okay, so if you want to put that as a template, you may. So x, -3 to 3, 7 numbers, right? And y, -3 to 3. -3 has to be in the bottom, 3 in the top, because that's the way it's on the xy coordinate system. So 7 by 7, and now you're going to fill it with 49 numbers. Okay? So same thing for all of these. Number 10, -3 to 3, -3 to 3. 12, -3 to 3, -3 to 3. Okay, here's a differential equation. Y prime equals half y. So let's see, I know what I'll do. Take All right, so y prime equals 1/2 y. Come up with the slope field. Okay. All right, so go from -3 to 3, -3 to 3. In the book, okay, I mean, they've got so much stuff here. This is from 0 to -2 to 2. So they've got probably, I don't know, 0.2, 0.4, 0.6, 0.8, 1, right? 1.2, 1.4, whatever. You can let a computer do that very easily, but you and I don't want to do all that stuff. Okay. So I just want you to do, quote unquote, only 49 numbers. Okay, now how do I fill in this box? Very easily. You take the ordered pair. So this corresponds to -3, 3. This is the origin, 0, 0. This point here is 3, -3. This is 3, 3. -3, -3. This would be x equals 2, y equals 1, and so on. Okay. If you stop and pretend this is an xy coordinate system, right? Pretend this is an xy coordinate system. This is where the origin would be. This is where 3, 3 would be. This is where -3, -3 would be, right? This is where -3, 3 would be. This is where 3, -3 would be, and so on. Take the ordered pair and plug it into the differential equation. Fortunately, for this easy differential equation, it doesn't involve x. Since it doesn't involve x, I'm only plugging in y. So since it doesn't involve x, all of these numbers are going to be the same. So here y equals 3. Plug it in, 3 over 2. So all the way across, 3 over 2 for this first easy example. How about all the way across for 2? How come they're all the same? Well, I would normally plug in for x, but there's nowhere for me to plug in for x. There is going to be plugging in for x for these other ones that I'm going to show you. But right now, there's nothing to plug in for x. I plug in y, 2, half of 2, 1. So all of these are 1. Plug in 1, 1/2, all the way across. Can you guess the next one? 0. 1/2 times 0, 0. Doesn't depend on x. There's no x to plug in. It's only dependent on y. -1, -1/2. -2, -1. -3, -3 over 2. Okay. Yes, in actuality and in the actual exam, you'd have to fill this all out. It's not going to be this fast. Okay, but you know, I already did it, so I'm just going to show it to you as long as you get the concept. But yes, you will have to do one of these perhaps on the next exam all on your own. Fill out these 49 numbers, 7 by 7. So you can start off with this template, -3 to 3, 3 to -3, and then fill in. Okay, now what do I do? So I draw myself, ignore all these lines, ignore all the red, ignore everything. Just draw -3 to 3 for x, -3 to 3 for y. Okay? Temporarily pretend that these little lines aren't there. Okay, so 49 numbers. So all of these are what you get when you plug in. That's equal to y prime. What does y prime mean? Slope. So I draw myself at each of these points a tiny little stub that has that slope. Now in Algebra 1, once you have the slope, you would draw the entire line. But since the slope keeps changing, you just draw a tiny little stub, so to speak. Okay? Just draw a tiny little piece that has that particular slope. Let's start right here. Y equals 0. All the slopes are 0. All these slopes are 0, so I just draw, I don't know if you see that red, I just drew it a little bit above there. All of these have a slope of 0. When y is 1, y prime slope is 1/2. Okay. Now you're just kind of aiming at it. Okay, 1/2 means over 2 and up 1. Okay, so I would join these two if I were in Algebra 1. I would draw the entire line. But instead, you just draw a tiny little stub, that's 1/2, and now all the others are going to be parallel. since parallel lines have the same slope, I just draw a whole bunch that are aiming the same way. And same for all of them. Here I have, when y is 2, slope is 1. Slope is 1 means it goes up at a 45-degree angle, like that. Okay, so there it is. And then slope of 3 over 2, 1.5, just make it a little bit steeper. That's kind of off the graph now, but that would be over 2 and up 1, 2, 3. Just kind of aim it in that direction. Okay. And now the negatives. When y is -1, slope is -0.5. -0.5 means over 2 and down 1. So I'm aiming it in this direction. But again, just a tiny little stub like that. And all of these are -0.5, so I just try to make all these other parallel to it. So all of these are supposed to be slope of -0.5. Y is -2, slope is -1. -1 means falling at a 45-degree angle, or like this. This is slope of -1, right? Falling at a 45-degree angle. So -1 all the way across when y is -2. And then steeper still, the last one, -3 over 2. Okay, that would be over 2 and down 3. Okay, just make it a little bit steeper. And there you go. All right, now they ask you to make 3 solution curves. You should have 3 fundamentally different solution curves based on this. And you can see there's 3. There's one on the equilibrium solution, y equals 0. And if I drop something above, it looks like it's curving up. And if I drop something below, it looks like it's curving down. So here are 3 fundamentally different solution curves. One that goes right along the line y equals 0, or the x-axis. If I'm above, it curves up. And if I'm below, it looks like it curves down. Okay. So that's our first example of a slope field. Okay, so overall scheme again. Start off always with this. How do I fill these 49 numbers, 7 by 7? Okay, we're going to go just from -3 to 3 by -3 to 3. By the way, this x is sometimes said as cross. You'll learn more about that in Calc 3, perhaps. But this cross this means this is the extent of x, this is the extent of y. Okay, so you take the x and the y and plug in. For this particular example, there's no x to plug in. So you just plug in the y. So all of these are 3 over 2. All of these are 1/2 times 2, and so on. All of these are 0. Okay, so this is our easy one, so to speak. This is the easiest case where I didn't have to plug in for x. The next ones, though, you do have to plug in for x. Okay, so number 10, y prime equals x minus y plus 1. So you always start off with this, -3 to 3, -3 to 3. Please notice -3 to 3 for x, but for y, 3 is at the top, -3 in the bottom, because that's the way it is on the number line, right? Okay, so this time I have to plug in x and y, so that's going to be a little bit tougher. Okay, but there are some things that I recognize here. Okay, here are the numbers, but when you're actually filling it out, how can I make it easier? Here's one thing that's true. If x and y are equal, then y prime equals 1. Do you agree? So I plug in 0 and 0, 1 and 1, 2 and 2, 3 and 3, -1 and -1. I'm going to have 1. So that means along this main diagonal, it's all going to be 1. 1, 1, 1, 1, 1, 1. Okay. We're trying to look for patterns, if possible. So these are all 1. Okay. Now, maybe let's just look across for some of these. Okay, x is -3, y is 3. So -3 minus 3 plus 1, -5. How about -2, 3? -2 minus 3 plus 1, -4. -1, 3. -1, -3, +1, -3. And yeah, usually by now you say, okay, I got the pattern. And for these, you're probably going to be right. -2, -1, 0, 1. Let's take the pattern going down. -3 and 2. -3 minus a -2 plus 1. -4. How about -3 and 1? -3 minus 2 plus 1. Sorry. And -3 minus 2 plus 1 is -4. -3 minus 1 plus 1, -3. Okay, same thing. I got the pattern. And frankly, once you got the pattern, you can just fill out the rest of it, right? It's almost like Sudoku, kind of. Okay, so you got that, and you know the way this is going. So it looks like we go this way, you keep adding 1, and you keep adding 1 this way, and you just fill in the whole chart, right? So it's actually not that bad quite often once you get a pattern. Let's double check this one. 3, -3. 3 minus a -3, 6, plus 1 is 7. Okay, so the chart's all filled out. Okay. Now, it's almost like you do this. Take these 49 numbers, place them directly on the grid. Okay. So in other words, pretend this is -5, -4, -3, -2, -1, 0, 1. Going down 1, 2, 3, 4, 5, 6, 7. Going down here, -5, -4, -3, -2, -1, 0, 1. Okay, going across here, 1, 2, 3, 4, 5, 6, 7. Okay, the only difference is instead of writing those numbers, imagine you have these 49 numbers here, but instead of writing the numbers, you just draw a tiny little line segment that has that slope. Now, for most of these, it's hard to get very accurate. We don't really care. We're just looking to make it steeper. Well, you should be able to come up with a slope of 0 and 1 and -1, right? Slope of 1 goes like that, 45-degree angle. Slope of -1 goes down at a 45-degree angle. Okay. These other ones, for the most part, you can just make them steeper. Okay. You don't have to make them that exact. Okay, so all these zeros right here. Okay, so I know it's going up at a diagonal. So this is the point -1, 0. Right? X is -1, Y is 0. X is -1, Y is 0. Okay, so that's right here. I draw a little horizontal stub. And the way the pattern is going is I go up at a 45-degree angle, and all of those have a slope of 0. So horizontal, 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 horizontal. Okay. Below all the ones that had zeros are 1. In particular, the origin was 1. Look over here, if I plug in 0, 0 minus 0 plus 1, 1. All right, so the origin, where is that? Is right here, right? 0, 0, 1. So the origin, I have a slope of 1. And then if I go up like that or like that, so these are also 1s, 1, 1, 1, 1, which means it looks like I have a straight line right here. So here is one solution. If I drop a particle right there, it's just going to go along the line y equals x. Okay, from there, I just sort of do the steeper game. Okay, 2 you can maybe do. So below 0, 1, 2. Okay, it's 1, 2. All right, slope is 2. That's over 1 and up 2. I'm just aiming it in that direction. Okay, so remember in algebra 1, once you had these 2 points, right, you would draw this entire line. But we're not. The slope keeps changing. So I just draw a tiny little stub like that. And all the other ones, I just make them parallel. So I make that one slope 2, slope 2, slope 2, slope 2. And then after that, I just play the steeper game. Make this steeper. So 3 is a little bit steeper. That matches, that matches, that matches. And then 4 is still steeper. And then 5, 6, and 7 is the steepest still. Okay. So you know, I didn't really measure this one for 7. I just made it a little bit steeper. Just have it angled up a little bit more. Okay, and then all the negatives. Okay, above slope of 0 is the slope of -1, or here. Okay, let's take this point because this is the point 0, 1. So let's see, 0, 1, slope is 0, right? So here's 0, 2, slope is -1. And it looks like these are all -1s going this way. Okay, so dropping at a 45-degree angle, and same thing there, 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 and there. And then again, I just played the steeper game. Okay, -2. This is the point 0, 3. X is 0, y is 3. X is 0, y is 3. -2. I just made it a little bit steeper. And -2, -2, -2. -3, I just made it a little bit steeper. -4, steeper. -5, steepest. And there we go. Okay, then for 3 solution curves, okay, so it looks like y equals x is 1. If it dropped anything below, the way the lines are going, it looks like it's curving this way. And if I drop something above, it looks like it's curving this way. So it looks like everything is curving toward y equals x, so to speak. All right, so there we go. By the way, this is beside the point for now, but y equals x. If I'm on this line, what's the slope? 1. Y equals x. If y equals x, what does that mean about this expression? X minus y. 0. 0 plus 1 is 1. Slope equals 1. And that's true. So if I'm on the line y equals x, the slope is 1. So we definitely know y equals x is a solution to this differential equation. But that was kind of beside the point. Okay, so I have that. All right, number 12 is the last one I was going to do. What time is it? Almost 8 o'clock. Okay, so I'm going to finish this one, and then I'm sort of done. So we can break, but I was just thinking if that's all I'm going to do, I might as well just go ahead and give you the quiz, and you can break as you wish. And, you know, if we're going to break it and do the quiz, you might as well just do the quiz, and you can break whenever you want also, okay? So let me just finish 12, and then that'll be it. This one, unfortunately, is a little bit harder. And yeah, next time I'll be doing that other topic, Euler's method. Okay, but I'll worry about that next time. Okay, so y prime equals xy minus x squared, and the point is 0, 1. Okay. So this time, I thought it was better to factor out the x times y minus x. Okay, so I decided not to show you the graph for this one. You can do it on your own, but so whoops, the reflection there. You always start with this, x, y, -3 to 3, 3 to -3. If you want to put this on your cheat sheet, you may. Okay, this one you can tell the computation's harder, but here are some things that will help. Okay, what happens if x is 0 to this whole expression? Automatically 0. So notice when x is 0, 0 is all the way down. That makes it nice. Okay, and another thing I noticed, what happens if y equals x? Like 1, 1, 2, 2, 3, 3. Again, you get 0. So along the main diagonal, I have zeros also. 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, -3, -3, and so on. Okay, after that, it's not so nice. Okay, but there are some things I can make a pattern out of. Okay, let's look at x equals 1. If x equals 1, what's 1 times that? Well, it's just that. So it's just y minus x. Okay, so along this column, where x equals 1, all the way straight down, I'm just going to do y minus x. Okay, so here we go. 3 minus 1, 2 minus 1, 1 minus 1, 0 minus 1, negative 1 minus 1, negative 2 minus 1, negative 3 minus 1, and so on. Okay, so sometimes you can look for patterns like that. There's not too many other nice patterns, but maybe the only other one I'll show you is this one where I kind of messed up. How about x equals negative 1? Put a negative 1 here. It's negative 1 times y minus x. Negative 1 times y minus x is x minus y. Okay. Again, put negative 1 times that. You just turn it around. X minus y. Okay, x minus y. Negative 1 minus 3, negative 4. Negative 1 minus 2, negative 3. Negative 1 minus 1, negative 2. Negative 1 minus 0. Well, by this time you got the pattern. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Okay. And then you keep going for all the rest. Okay. Again, all the rest, most of them aren't that nice, but we can see some nice patterns. Okay, let me go down to column of x equals 3. Put a 3 here. Okay, 3 minus 3, 0. Got that? Okay, so this is a 3. Let's see. 3 minus 2 is 1. Let's see. Sorry, it's y minus x. 2 minus 3 is negative 1. Negative 1 times 3 is negative 3. Yeah, sorry about that. Okay, next one is y minus x. 1 minus 3 is negative 2. Negative 2 times 3 is negative 6. All right, you should be able to get the pattern from there, right? 0, negative 3, negative 6, negative 9, negative 12, negative 15, negative 18. Okay, and something similar happens to all the rest of these, as it were. Okay, so here's the entire chart. Okay, I'll let you check. I mean, it's basically just arithmetic and a lot of plugging in. Okay, obviously, you're going to need to take much more time to do it on your own. Okay, but we can just randomly check some of these. How about I check this one? Negative 3, 3. So negative 3 times 3 minus a negative 3. Negative 3 times 6, negative 18. And so on. How about just for fun, let me try negative 2 comma, I don't know, 1. Okay, negative 2 for x and 1. So it's negative 2 times 1 minus a minus 2. That's negative 2 times 3, which is negative 6. And so on. Okay, so since I already did it before, yes, this is rather fast. But when you actually do these things, as you can imagine, it's much, much longer because you have to do 49 calculations, right? Yours is going to start blank like this. And it's just, you know, a lot of work. But once you see a pattern developing, right, like here, 0, negative 3, negative 6, it's almost guaranteed for these problems, it's going to work out the way you want it. So then, oh yeah, negative 3, negative 6, negative 9, negative 12, and so on. Okay, let's look at this one. See, after I do maybe 3 of them, if you plug these in, negative 10, negative 8, negative 6, okay, you got the pattern, right? So negative 4, negative 2, 0. Oh, we already had the 0, so that kind of double checks it. And then 2, and so on. All right, and then you go from there in terms of making the chart. I decided not to draw the chart for this one, but you can make it up. And just make everything steeper. So all of these are going to be horizontal, slope of 0. The next ones are slope of 1 and negative 1. Unfortunately, this one doesn't seem to have that many 1s and negative 1. So slope is 1. It's going to go like that. Negative 1 is going to be like that. And then the rest, just make them steeper as necessary. Right? Well, negative 18, that's very steep. That's almost vertical, very steep negative like that. Okay, so I'll let you work on that on your own. Okay, I'm basically done. All right, so I'll stop that. I'm going to check the chat for a moment and then get ready for the quiz. So you can break if you want to, or if you want to just go straight to the quiz, you may. Okay, check up on the chat. We have to work out the solutions for 1 and 2 part B. Okay, so find the equilibrium solution. You might have to If for both of those, it was just involving some trig, but you pretty much can get it off the graph. Okay, so if you look at the graph, there was a 0.5, 1.5, okay, 2.5, 3.5, and so on. Okay. Let's see. Do we have to show each individual calculation? No, if you just go ahead and, okay, you just go ahead and fill out the chart like I did, that's okay. Okay. How long do you have for the quiz? Well, technically you have until Tuesday. Okay, so we would normally break, but I figured out you can break and or go straight to the quiz. So we're done today, folks. So in class you can go all the way to 9:25, but if you want to end earlier, you may end earlier also. Okay, so anybody have a quick question they want to ask me right now? Otherwise, I'll go straight to the quiz. But if you want to break, you can break, and whatnot. Okay, so get out your cell phone. Okay, so this is on arc length and surface area of revolution. Let me get this set up. Get your cell phones out while you're at it. All right. There's a lot there. Okay, go ahead and take a picture. I'll blab a while. You can get started, but you say, I don't even know what's going on. Okay. I gave you a quiz before where you proved the formula for the volume of a cone and the formula for the volume of the sphere. Okay. I kind of alluded to these, but now you're actually going to do it. Okay. You're going to come up with a formula for the circumference of a circle and for the surface area of a circle, both of which you should know. I gave you the surface area of the, surface area of the sphere. Okay, x squared plus y squared equals r squared. Circle, center of the origin, radius of r. Number one, solve for y in the first quadrant. That's easy. 2, consider finding the arc length of the graph in the first quadrant. Okay, so you've got an entire circle. If you're only in the first quadrant, what fraction of the entire circumference do you have? Right? Then use the arc length formula to find the length of the given arc. Okay, so once you solve for y, use the formula for arc length. You can look it up if you want to find the arc length. And then you're going to multiply that number by the appropriate number to get the formula for the circumference of the circle. You already know what the answer should be. The formula for the area, for the circumference of a circle. All right, so one more time. Strategy is work only in the first quadrant. Okay. Use the arc length formula once you solve for y. Use this. Find the arc length. Multiply by something. And you get the formula. Number 3. Take that region, spin it about the x-axis. What fraction of the whole sphere do you see? Okay, just the first quadrant, spin it around. Again, you have a fraction of the whole thing. Use the surface area formula to get the surface area of the region. Again, multiply by something, and you're able with the formula for the surface area of a circle. So it's a little bit more challenging, but look up the formula for arc length. Look up the formula for the surface area of a sphere. Okay, so you already know what you're aiming for, so to speak. Okay, so let me make this disappear. I'm assuming you all have it by now. I will set up your breakout rooms, but if you want to break or half break and half work, that's perfectly fine also. Okay, and let's see. When are we having the third exam? Still according to schedule. So what was it on the schedule? Exam 3 is October 22nd. Looks like. Okay. So if I end up finishing early, that's okay. I'll just keep going from there. Okay, so let me set up your breakout rooms. Give me a moment for that. Then you can work as long or as short as you want. I highly advise you to talk it up with each other, saying, what do I do here? What do I do there? You know the circumference of a circle, so you know what you're aiming for. Maybe you don't have memorized the formula for the surface area of a sphere. I did give it to you the last time, though, if you look at your notes the last time or the previous video, or you can look up on the internet also. Okay, so as usual, due at the beginning of class next time, so what, 7:10 p.m. next Tuesday. Once I put you in your breakout rooms, you can go as long or short as you want, all the way until 9:25, and I'll be here in the main room if you need me, unless I'm joining some other breakout room, okay? All right, so let me try to set up your breakout rooms. All right, you've all been invited to join a breakout room, so you can all join your breakout rooms, and you have all the way until 9:25 if you wish. If you want to leave early, you can.
Mr. Home, for solving for y, are you just mean by putting the y on one side and the other things on another
Yes,
side? Okay.
should be y equals blah, 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 blah.
Okay, okay.
Okay, all right. Okay, everybody please join your breakout room. Okay, Hal and Kenneth, please join your breakout room. Hal and Kenneth, please join your breakout room.
Hi, Mr.
Hi.
Hunt.
Guys, you need help?
Yeah, I was kind of confused on just the first question, for finding the arc length.
Mm-hmm.
Yeah, I was trying to do the formula, like the L equals the integral from A to B, but I was like wondering, like is A to B, is that like 0 to R?
Yep,
Oh, okay.
you got it, from 0 to R.
And
That question is actually very similar to one we did in the homework. If you look back at the arc length homework, I believe it was problem 2, is very, very similar to that one.
okay, thank
Okay.
you.
All right, you're welcome. Anything else for you guys? You guys good? Okay, you're not saying anything, so I will leave. All right, you guys okay?
I'm stuck on the second question.
Question 2?
Yeah.
Okay, so you used the arc length formula. That was from
Yes.
the first section. In
Yes, I'm
fact,
stuck on the algebra part.
oh, okay. Algebra is supposed to be the easier part. But... Okay, were you able to solve for y?
Yes, y equals square root of r squared minus x squared.
Good. You got it. So use that, and you'll be integrating from where to where?
0 to 1?
0 to r.
Oh.
Okay, so when you guys integrated 0 to r, so you have to use the arc length formula. And if you want a hint, this problem is very similar to 8.1 question 2, which should already be in your notes, or if not, it's on a previous video. 8.1 question 2 is very much like this one. Check that
Yeah.
out later. Okay. Yeah, so that's the hint I'm going to give you now.
Okay.
All right, but that's about it. Okay. All right. You guys have any other questions? Okay. I will disappear, but if you need me, just holler for me. I think there's an option that you can ask for me later. Okay. All right. See you guys later. Hey, you guys okay?
Yep.
Yeah.
Yep.
So.
All right. So far, so good? Okay, good. All right. Mm-hmm.